before, my name is Pitt Fagan. I'm the organizer of the meetup. And I'd like to thank our sponsors. So the pizza and the soda and the salad are courtesy of Cloudera. I don't see anyone from Cloudera here, but thank you, Cloudera, for sponsoring the food. After the meetup, like just a couple of minutes after, we're going to go for a sponsored round of drinks right next door over to the Ivory Room. That round of drinks is courtesy of Hortonworks. I don't see anyone from Hortonworks here, so anyway, I'd like to thank Hortonworks and Cloudera for their sponsorship of the meetup. Before I introduce Chris Bacco from DataGuise, I'd like to talk just briefly about a conference that I'm helping to put together with some people from Hortonworks and Cloudera and Red Hat. And it's the Big Data Wisconsin 2016 conference. I sent an email kind of teasing this a little bit a few days ago. It's scheduled for Monday, August 22nd, right in this room and next door. It's from 9:15 to 1:30. And we finally have a lineup of speakers, so I hope you guys can make it. I'll send out, obviously, more information about this, but our keynote is from Dr. Jignesh Patel, who's a computer science professor over at the university here. His title of his talk is How to Not Miss the Big Picture in New Big Data Initiatives. We have 5 additional speakers that are going to be talking about a range of topics. One is Bo Peng from Datascope. She actually runs the Data Science Madison meetup here in town, and she's talking about data science in the wild, wild Midwest. She's coming up from Chicago. Will Benton from Red Hat is talking about data-driven application architectures for containers. Dr. Philip Poon, who's right there, thank you, Philip, from Merida Unity Point, talking about using natural language processing to analyze electronic health records. And Glenn Fung, who's a data scientist or machine learning specialist, I guess, from American Families, talking about something that they're developing called ROCKET, which stands for Robust Knowledge and Concept Extraction from Text. So I'll send out more information about that, but I hope you guys can make it. We're looking to kind of get a whole bunch of people here and really launch this into something as an annual event moving forward in the future. So with that, I will turn it over to Chris Bacco from DataGuise, who's going to be talking about security in the big data ecosystem. Thank you,
All right,
Chris.
thank you. Thanks. All right, before I get started here, how many people are using Hadoop today? Small subset of people like there. Are you guys in production yet, or kind of science projects? The rest of the group, are you guys looking at Hadoop or any type of big data analytics solution? I see a couple heads nodding, yes, no, maybe. You guys still doing things typically today, like enterprise data warehouses with databases, yes? Teradata? No? Okay. Do you guys, how many people here have any type of project to create some type of data lake or data democracy? 1, 2? Okay. For the big data group, I'm like, I don't see like a whole lot of big data things happening here anyway. The rest of the group, you guys interested in what big data is bringing, or are you guys looking at like what's kind of like the next step or next phase of it? This is actually not too uncommon, to be honest, for a lot of the cities and groups that I've presented from. At DataGuise, I have a multi-state territory, and it's interesting because there's people that have been very successful with big data, and you see inside those organizations, it's moving very rapidly, like everybody going to it, right? One of the customers I worked with, I'll talk a little bit about how they use our security solution, how they created data democracy, and now it's like the hottest thing inside the IT department, and everybody's trying to become part of it now, because everybody wants to get data reporting out of it, because they created new products, right? So it's kind of a common theory. I'll try to, as I talk through it, talk a little bit about some of the examples here, and the reason I ask those questions, because everybody's kind of at a different area or phase when they look at creating data lakes or big data, right, and big data analytics there. So some of the terms are relevant to some people. Some of the people's things to think about when you go and do it, right? Because our company provides sensitive data detection and protection, and I'll talk a little bit about that at the end, how we do it and how it pertains to different types of data and where you can use data. So we typically come early on. People look at it like either security or protecting it if they want a lot of people to use data, or people look at it, they call it the it moment, afterwards when somebody accesses the data or something happens to the data, and that's where you come in, right? So there's a large credit card company that my peer works with, had been working with, and they didn't see it. You know, they had a PCI PII audit, and there was tons of data in their Hadoop cluster that they didn't know about that was sensitive. And this also comes from the world when we start to look at, when we start talking about data, there's structured data, right, databases, and you start moving towards unstructured data, and even inside databases or inside Hadoop. One of the customers I'm working with, one of their biggest challenges, they're going to store all their customer service chats. They were storing in databases. They're all going to put all that information off the web. And they're just going to dump it all into Hadoop because they want to then do analysis to see if there's patterns, right? But the problem with that is it's all unstructured. And what is inevitably, when you go to any online chat at a bank, healthcare, your credit card, I just did it the other day too because I lost my credit card. As soon as I logged in, the first thing, what do they tell you to do? Don't type any sensitive data. Don't give us your credit card number or anything like that. And it's interesting because we work with 3 of the big 4 credit card companies we work with, and that's part of their thing is they grab all this unstructured data and they look at how do they protect that, right? Because inevitably it says don't type your account number in. The first thing people do is say, this is my account number or this is my information. So I'll talk a little bit about that. So you're starting to see data as a big asset, right? There's actually companies out there, if you keep track, that they're actually just selling data, right? Like that's the biggest asset on the books. One of the credit check companies I work with, they actually see that. Like their CEO sees the next couple of years, it won't be what they actually do. It'll be what they have as data and how they can provide that back. Because they're already starting to sell it back to healthcare providers, hospitals, finance companies, right? All your credit card check data that they have in there. And you've seen it's also the biggest vulnerability. I'm not going to go through any of that here. And I saw, it was interesting in this meetup, someone, I don't know who responded to, but they responded like, oh, you ever go to the grocery store and you put your credit card, and that was you, and you can see everything, yeah. I mean, they know everything about you, right? So data is everywhere, data is valuable, and data is very rich. So the person who kind of put some of this presentation together, and I'll talk about what he did, he works for DataGuise. He's a PhD doctor, Anhad Singh. He did his whole analytics around that the data that you find can find you, right? And his whole thesis and paper behind that was, how did everybody start storing data? They started storing data because disk became cheap and you could just store information. So he goes, you no longer had to purge it or weed it out there, right? So it's a valuable asset to you, and it's also very risky to the data that you have. So this is one of the things that he used when he did his doctorate on security, is AOL Stalker. People aren't familiar with it. This is, it's been taken down for about, 6-7 years now. But it was a thing AOL had in here that called AOL Stalker that someone created, that you could actually type information or email addresses about people, and it would basically go out and search everything that's related to that person and bring it all back to you. So if you knew somebody's piece of information, like a name and a birth date, you could actually query it. This would spider everything they could find across the web and then provide all that information back to you. And it was, health insurance, your cars you drove, loans, license plate numbers, everything. So that's when he started writing this paper about this, was that it's easy to discover things about people by just putting a few events together and linking those together, and then that being exposed.
Was that a free service?
It was a free service, yeah. You can still Google it. People are like, is AOL Stalker coming back? Is AOL? So it was a service that someone had created out there and thought it'd be great that you could search and find anything about it. You can still kind of do that in Google to a point, but this is to a point where it could tell you like your home IP addresses that were attached to your name, to your internet service and your providers, right? So you can get very personable information out there. So obviously at first
you have to pay for it.
Yeah.
So, I mean, most of the services today.
Well, you have to pay for it, yeah. And this is kind of how it started, and this obviously got taken down pretty quickly, and people realized that. But that goes back to the thing where you don't realize the sensitive data and how close you can get to it. One of the things out here that was done was that from the federal government, LaTanya Sweeney put this together. She actually did a research, and this is, again, you can Google this and find all this information out here. But if you can actually find somebody's date of birth, gender, and zip code, you have an 87% chance of uniquely identifying that individual person, right? So we start talking about big data, and we start talking about securing big data and sensitive data, and I'll talk more later, but you see that a lot of the customers and individuals that we've worked with are people that you've talked to across this big data platform. The first thing you talk to the security team is, we've got a firewall, right? And we have access control. No one can get to it. We're all good. But then the second problem is you're starting to see like the larger attacks that came in the world, the anthems and the targets, somebody was already inside, or somebody had access to that data, right?
Is that the zip code of where they live now or where they were born?
You look at the actual current zip code, you can find that in there. If you find given date of birth, gender, and place, and I've actually worked with healthcare providers multiple times. We talked about security, and they're very adamant that if you can find just a couple pieces of information about a person, you can find out like when they visited a doctor. You know, like I'm from Chicago, you can find my birth date and find out that I had the flu. You'll find Chris Spackham. So it's amazing how you see how this is so predictable that when you see the data is there. So some people, when they look at this, they tend to forget like how important big data actually, the data is, and the data people are accessing. And especially when you start looking at, like I talked about earlier, when people are creating these data lakes, there's one of two things. Either you lock it down, right? One customer I work with, the data lake that they have there that they do analytics off, 6 people in the entire company, they have 5,500 employees, have access. There's one person from security, one person from IT, and 4 data scientists, and that's it. And everything they say inside there is sensitive, and no one else can have any access or control to it. So they're like, okay, the data's locked down, that's fantastic. But then you look at the other side, what's the whole point of having the data, right? Is the ability to do analytics, the ability to create new products, the ability to look at different things inside the data, right? You look at data analytics that are driven. You look at new companies like Uber does predictability, TrueCar, right? When they sell cars, find your locality, you're in Madison, Wisconsin, your demographic of your age, what you're looking for in a car, they find the best price for you. They can also determine what kind of car you're gonna buy. They can also determine you're gonna buy a car after the Green Bay Packers win the opening game. And it's true, like they actually have pattern analytics to prove that when their sports teams win in cities, more cars are actually sold. Like, and they don't have that data, they're taking all that data in, right? So again, if you can find date of birth, gender, county of birth, 18% chance you can find an individual, right? So that's the problem. So you start looking at it, it's like, today there's too much data. Do you know where your data is, right? So if you have an application that uses a database, most people actually know that and know the structured data inside there and know where sensitive data lives. But when people start creating enterprise data warehouses, we're taking in multiple data sources from different areas. And we see this especially within Hadoop, right? You'll take files in, they'll take things. It's interesting because I'm actually seeing more and more Hadoop becoming almost database offloads in there to do reporting, and then you're adding a second data source inside there to see if it's faster. One of the Blue Cross Blue Shields I work with, they're taking everything on Oracle, putting it in Hadoop right now, and they're just purely doing that from reporting and speed of process, right? So things that used to take them hours to run, they can run in minutes on Hadoop. The second phase of that is they're also looking at historical legacy stuff they had in other databases and repositories to then put that in there instead of creating reporting across that right now. And then you start talking about it, especially in big data, how do you control access, right? Like my one example was 6 people, that's it, right? Or when you start looking at the big data analytics inside there, do you do it through group policies? Who can see what data? Do you know all the data that's inside there that you're accessing in there? And then the same type of thing is like, how do you share the right data when you look at data analytics or data mining, right? When you start asking all these questions, when you start looking at building a data lake, right? Who wants to use that? Who's going to get value from it? Is it just one specific group of data scientists? Is it a specific group of marketing, analytics? Is it new products, right? A couple of the customers I work with, they've actually created, and I'll talk about it a little bit through some of the access control methods, allowing everybody to access it. So it went from 20 people to 145 people now have access to it. And you'll see that they've done some things through security, like masking and encryption, to change what people actually see and be more creative to it. And they went in the mindset saying, the first group that was accessing it, eventually we're gonna let everybody come in there and figure out how do we do it, right? Because it doesn't matter, anybody can come up with a new solution or product inside there. There's a high variability in data too, depending upon how it is there, right? Is it databases, Hadoop? Is it file system? Is it SQL? Cassandra? Is it MongoDB? Anybody using like Cassandra? One person, MongoDB? Is there technology? Any NoSQL technologies? Oh, a couple there. All right, so there's a good mix inside there. So you see that again across all the different technologies inside there. Multiple file types, right? I think in the Hadoop, that's probably one of the biggest things that I see inside there when I talk to customers. Some customers have created data lake and they've just dumped all sorts of data in there and they're not even sure what it is or what file types are in there. And you laugh, but I see more of that in the actual medical fields, right? And like, you know, EDI is a specific medical field. They'll have all sorts of different EDI files, and they'll have different types of zip files, or RAR files, and things that they can't even open or access in Hadoop. So again, that's also part of the process when you're going to ingest that. You know, now they're starting to parse everything and then dump it all into text files. So there's a lot of stuff being done inside there, and exactly kind of what's in those files, right? Structured data, unstructured data, semi-structured. So you start to see that there's a big mix when you start to look at data when you go in there, and how do you protect this data, right? It's easy when it's structured, and I know exactly where it is, right? But what do I do if it's unstructured? Do I protect everything that's unstructured inside there, or do I not protect everything? Is there elements that I want to see inside there and do some of the reporting? So that's one of the big things that we see in here. This is an interesting report when you actually look at it. 16% of all his respondents, and I'll give you the presentation so you can see this with the survey inside here, believe they actually know where sensitive data exists in their environment. And it's interesting that they probably didn't interview everybody from security, because if you talk to anybody in security, they say they know where everything is. And then you talk to anybody that runs an application, they say they know where it is. And then as soon as you get farther closer to the business, or you get to where they're ingesting data, or they're going to start doing the analytics, that's when you get the one guy who's like, we have no idea where any sensitive data exists, right? And he's like, I hope, you know, through firewalls and access control, we have all that protected inside there. And then 79%, they say they know where the organization that sensitive information represents and represents a significant risk, but they don't do anything about it. So this is when they ask actually CIOs that they know about the data, they know it's sensitive, and they assume they have enough control about it, and they're doing nothing about it or nothing with it. And then you see 51% believe that security and protected data is a priority in their organization. So only about half the people think that that's actually an actual priority, right? And there's other things to do inside there. And some of this, I'll go through a couple of these things here, a little bit just marketing, but it's interesting to see when you look at the consequences of it, right? Internally lost productivity, lost revenue, right? Everybody knows these things, legal costs, litigations, fines, customer losses. It's interesting, being in a security company now, you see that I mentioned a little earlier, you know, one of the customers that was looking at our solution, it's been going on for a long period of time, they failed a compliance audit, and they had 90 days to solve the problem. And you know, my peers they're finishing up a purchase right now. More of that was just detecting the data than actually securing it, because they didn't know where the data is inside there. And then this is one of the things I'll start to talk a little bit more about, some of the different methods and things we see inside there. Again, another report. You know, it's any data center outage, it's an attack or it's like human error, right? On the data center side, I mean, I was the same way. I was at VMware for 8.5 years. When I was there, any outages we always had, even on the VMware side, it was usually user configuration and error. Like if something always failed there, almost more than attack. On the security side, there's actually hackers and insiders. And you also see about, and I'll talk a little bit some of the security, the next tier of security products, not even from DataGuise, but from other customers that we're creating a solution to in a way a little bit. They're actually creating tools that just monitor sensitive elements inside of your data to alert you that if somebody's pulling records back, right? So if somebody's pulling social security numbers, or someone goes out, and Chris Spack was in Mexico for the week, and suddenly I pulled back 50,000 credit card numbers. You know, oh, and by the way, I just turned in my resignation at the same time, right? You know, someone will probably want to know about that. But you're starting to see, like, those are the next tier type things, is that everything you look at in security, you keep having to go a layer deeper and deeper and deeper to look at that. And you're starting to see, like, access is a little different, right? When you start looking at the data and stuff there, is you hear the democracy of data. When you create these data lakes, everybody wants to get to it, right? So the one customer I talked to, they have 145 people accessing it across, I think it's like 30 or 40 different business units. All those business units are dumping all their data into their Hadoop data lake they're reporting on. I mean, it's like petabytes, crazy amount of data. but across the entire organization, it was done down that they want to, everybody have access to it, everybody create any type of reporting structure of the products, and have unfederated access to that data. And talk about it's like gaining enterprise-wide insight, right? Like can everybody access that and go after it? And then this is really it. When you start to look at it, the biggest thing you see inside here is the security impact is the one customer I worked with, right? 6 people access. You go to the second customer, 145 people accessing it, right? Is everybody as cautious? Is everybody in there? And you start looking at like, what are semi-trusted users and how do you identify someone that might be a semi-trusted user inside the data? And how can you provision new users? What if you add new data streams in there, right? So one of the customers I'm working with in the Midwest, they work with healthcare and hospitals throughout the US. And it's interesting because like the group ID, group policy number are most critical to them. Certain states, I've learned things are critical, right? So California, only certain individuals like doctors and nurses can see HIV status, yes or no. Other people, it needs to be, that status needs to be zeroed out, but they still need to know people's ages and other things about those individuals to do reporting or statistical analysis for their insurance organization. But there's actually certain fields based on state and carrier that those individuals that do the analytics technically cannot be seen ever, but it's part of the medical record, right? So they're trusted users, but there's data that's inside there that they're not allowed to have access to. So when you start talking about what you do when you start looking at big data, this is typically what individuals and most customers and companies do, right? And this is amazing because this technology has been around for what, like 20, 30 years now? I used to joke, some of the customers, Dr. Anand Singh, when he was talking with one of the customers, he goes, when they were trying to talk about how they're protecting their Hadoop data lake and what they were doing was adding security, he goes, all you guys are doing is actually digging a bigger moat. And he goes, you don't understand. He goes, that's great technology. He goes, if they're going to try to come through the front gate or the front door, but he goes, what if somebody's actually inside already? The moat doesn't stop anything, right? So that's when you start looking at typical things people look at. Okay, I have a firewall. I created VLANs. Kerberos, right? Users are authenticated, then they can get on the network and get access to all the data. But again, what if that's not the individual that's used inside there? Then you start looking at access control, right? So if you're talking Cloudera and Hortonworks, right? You're looking at Ranger, for their access control, or you might have internal access control, right? Through like LDAP or security or groups that you create today. But what if that user has access inside there and is either a trusted or semi-trusted user and then can actually get to the data that they can see, right? So we've had this happen at other customers where someone's part of a group and then that group, an individual is allowed access to that group and suddenly just through going sideways, stepping across the data, they had access to all PII information, all PCI credit card information inside there. So again, those are some of the things you try to do inside there. Other things you do is you see wholeheartedly like file encryption or disk encryption, right? So I'm sure everybody here, you probably have, they're probably like, we have a firewall, we have access control established. Oh, and we do disk encryption at the hardware level, which is great if someone goes in and steals the disk and leaves the data center with it, it's encrypted. But everybody else that is a trusted user with access control, the disk is being decrypted for those individuals, right? Or being decrypted for those applications. So this is kind of, when you start to think about like the different mechanisms inside there, we start looking at the big data picture. And again, this really comes into the world, again, of Hadoop, or when you start to build data lakes inside there as you use the data differently, reporting on it, you have to think about, okay, the different security and the different access mechanisms, is that good enough, right? If I lock it down, is it good enough? Do I feel like disk encryption is a good enough resource? Do I want to federate everybody can access to it? Do I want to create data democracy, right? So I know a lot of people aren't kind of in the Hadoop, but I think you're starting to look at that or look at the data lake. And those are really a lot of the questions you have to ask that. And in pre-planning that, you can also determine how you're going to use the data, right? Because I think anybody that is Hadoop or you're looking at it, it's a crime when customers lock it down to only have a small group of people access that. When you're trying to use the full power of it, when you're trying to dump the data and then use the analytics from it. So when you look at this, any questions before I go on? So the solution, whether you look at things either from DataGuise, there's other organizations that do similar things that we do, and there's some that cross that. It's really like data-centric security, and I'll talk a little bit more on how you can actually do that inside there, and I'll actually walk through some of the customers that are using our solution. And some of the customers are using our solution for detection, and they're using other vendor solution for encryption or for masking, right? So it's not, it needs to be a one-all-fit-all. And it's really, when you look at this, it's creating that perimeter access that I talked about there, right? Authentication, network isolation, right? The next thing, after you secure that perimeter I talked about here, is access control, right? Who can access the data, who has access to it, and permissions and authorization. And then you start looking at data-centric security, you start saying, how do I protect the specific data that's in there at a data level? And we start looking at encryption, data masking. You look at element level encryption, element level data masking. I'll talk a little bit more about that. And how do you change it in there? And then when you create that, is how do you create visibility, right? So when people go in to do reporting, what do people see? Does somebody see all the data? Does someone see part of the data? Does someone see the data that looks like it might be real? Does someone use change part of that data? And I'll talk a little bit about this as one of the use cases, right? I have it in here further, but I'll kind of bring it forward. American Express, so they use our solution, part of it for just detecting sensitive data elements, right? So in unstructured data, trying to find credit cards. And then they use a different product to do encryption, but then they use our solution to do masking. And one of the things that we do in masking is we just change the center of the credit card numbers, but leave the beginning and the end alone. So they want to see the first 5 digits and the last 3 digits, but they want the other digits in the middle randomized or masked, so the credit card's not real. And the reason they do that is when they actually do fraud detection, they need to see part of the original number, and they need to see part of the end of the number, but you don't need to see the middle part of that credit card number, right?
Do they set it up so they can know who they created the data for? If a fraud use of it is named?
So the question is, they set the data up so that they know someone's using fraud for it?
Well, they customize it enough for so they have an idea as to where that point in time the data was stolen.
Yeah.
Who was at the keyboard, or who had authority.
So it's not at the keyboard because they're processing the data, so they're doing all this during ingesting.
I'm doing it kind of a metaphor.
Yeah.
You know,
But
whose
whoever swiped
fingerprints
it or whatever came
Yeah.
through, they'll look for that pattern to see that beginning and the end of the number, and then they match those numbers up to see where it came from, to see if it's a fraud alert. Because they're taking, I forgot it, I probably have it here, but it's like petabytes of information in from all the cards, and then they run analytics constantly on that, and that's why they need to see the beginning and the end of the number, but not the middle of it. And if they see those numbers that match up there, they look for patterns where it's being used too many times or being used 2 different places, right? Because I've had this, if you've ever traveled, you ever get those phone calls or something like that, the fraud detection? And again, they're looking for anomalies when you see it, right? I travel a lot, so like my credit card doesn't call me at all, except for when I bought $5,000 worth of jewelry off the internet one day. They said, I don't buy a lot of jewelry. So I got a phone call from American Express, I got a text message, and I got an email asking me if I wanted to buy if I just bought $5,400 worth of jewelry, you know, from Bergdorf's, I think it was in Dallas, Texas, and I was like, no. So they mask that, but then they keep the original values of like the individual, like person's name and other information inside there. So they also do another thing for a different group where they copy in Hadoop. They copy the real credit card and put it in one column farther, and then they completely randomize, mask the column before it with a fake credit card number. Does that make sense? So it's like,
Yeah, it's kind of like a hash of the credit.
yeah, it's a hash of it. So, you know, column 11 has the masked randomized number. Column 12 has the real number when they do that. So you can do, and this is for more of like a marketing and reporting and analytics. But there's individuals then that do have access to column 12 if they do need to find out the real credit card number and trace it back. But then again, that's limited to other individuals. So they have multiple, you know, use cases that they're doing it, and that's where I start talking about how it's more data-centric right, to individual certain data values or element levels than all the data, where they're not just gonna encrypt all the data across there, because they want users to get to it.
Isn't the first digit is the type of credit card, and then the next few digits, don't they identify the financial?
The banking institution, yeah.
Mhm.
For American Express, they're all coming in, as American Express numbers, because they're processing all American Express.
Right.
But somebody else could experience it like 5's MasterCard, 4's Visa, 3's American Express. So all the different cards are in there.
6 is Discover.
Yeah, and the Discover, 6 is Discover, yeah. So we actually have a customer that does promotional reporting. So they want to know the first digits of the cards, but they don't need to know the rest of the cards. They want to see who's using the card, like what card buys the most things of their product. Does that make sense? So again, that's another way to start looking at the analytics, that first value is very important to them, but the rest of it, no one really needs to know the analytics inside there. So I talked a little bit, this is kind of some of the things we do, and then I'll talk about other things inside there. So DataGuise, DGSer, one of the things we do is detect sensitive data. So if people don't know where sensitive data is, we can actually go out there and find sensitive data. So social security numbers, credit card numbers, group ID policy numbers, anything that might be unique to you, we can go out there and identify that. We can look through the whole file system, we can do sampling. One of the use cases, a customer of ours is going to move to the cloud. And they want to make sure they go through all their data and have everything identified before they make that move. It's sensitive in there, and either encrypt or mask the information that's in there. So again, you can't really protect what you don't know. And also, this is kind of the aha moment. Microsoft is a customer of ours from just the detection. So they were looking at moving their SQL databases to Azure. So shocker, they're not even using their own cloud. They are now, but this was about a year ago. So internally, they were looking to move a lot of their databases to their Azure platform. And as they started going through some of the process, they didn't actually know what was in there. I think there was over 500 databases. You know that, right? I was in IT before I went to the vendor side, and we didn't know what we didn't know. Like sometimes you'd be like, power the server off. Let's see if somebody comes in here and screams about it. If they do, then someone's using it. If not, we powered it off, and a month later, no one came looking for it. So it's like you wait another 90 days, another 120 days. I'm like, I don't know why it was on. It's like, this is why. Like you remote logged into a console, and like Windows NT came up. I'm like, what? I'm like, this is running NT. Does anybody know it? Is anybody even using this? Right? So they didn't know what they did, so they actually went through and did a discovery, which is interesting because then they questioned us because we were finding information, and we'll point to where it is in the database, right? But we don't store any information. We just identify tables, where it's located at, and then you can go get it. So they kept questioning us, so the POC lasted for weeks, because every time they kept saying there's no data, we'd find more data in there. So again, they didn't know the data before it, and then they moved it across, right? They're using their own SQL encryption solution after it, but they're using us for all the detection inside there. And then after that, it's protecting sensitive data, and it's across all the different platforms in there, and it's doing it then at the next tier, which is really, when you look at it, doing it at the element level, and it allows you a lot of different ways to use the data. And this is where I said that customers I work with, they either come in one or two ways. Early on, when they're planning, realize they want to do this, or afterwards, when they've seen that moment and they realize somebody accessed some data they weren't supposed to have data to, or you fail that audit inside there. So that's a big thing inside there. And you also look at the accuracy, right? Like people say, okay, I can write some regular expressions and do this inside here. We have pre-built policies, and policies can easily be customized in there. So you can find contextual information, machine learning. If you start looking also for like a social security number, right? You start going out there and you're looking for a 9-digit number. And if you just want to look for a 9-digit number, how many times do you think you're going to find a 9-digit number? Or part of a 9-digit number? A lot of times. What we'll do is we look for 9-digit numbers, and we look for contextual things like values of names or dates surrounding that, right? So for credit card numbers, we'll look for things for, there's a particular name, a date, a CVV code. So again, we're trying to be more accurate when individuals do there, because I've actually worked with a customer in St. Louis, and they do have an individual that does detection in Teradata, looking for sensitive data, and they do it where they've written tools to do it in databases. The problem is that they're going to move all that off of Oracle, off of Teradata, and want to put a lot of it on Hadoop, but it's a cost savings to them, and it's significant to like millions and millions of dollars to a 16-team project person. There's things that they didn't catch, right? So we went and ran a POC and we caught some more numbers than they did. But again, I had one customer who wanted to look for 13 numbers and kind of did star, 13 numbers star, and wondered why it ran for a week and didn't pull any results back. And there was petabytes of information, and we found, thousands of records that we thought were false positives they turned out to be. Again, so if you know something about your data, right? Like one of the healthcare institutions I know, they have a group ID number, which is 10 digits long, but they know it's always going to be before or after will always be a date to that number, because that's when it expires, the insurance policy. So again, you do that contextual search and you can find that, right? So that's part of the thing inside there. There's sampling we can do, predictive analytics. I'll kind of go through a little bit some of this here. Lots of customers partner with everybody we do. And I'll talk a little bit about some of these use cases here. Samsung, it's interesting. Whether you know it or not, they collect all the information about your phone. Did anybody know that? Like, no matter what phone manufacturer it is, they do phone logging for error reporting and like statistical bugs, but they don't create other information outside of that really. But if they get your phone, like your MAC address of your phone, remember I talked earlier how if you have a couple of data points, you can actually follow the person back. They can actually follow the person back. So they get all that reporting out there, and they use our detection to go through and look for all those phone IDs, and then as soon as they find them, they mask them with artificial numbers, but they look like they're real numbers, but they still can then do all that error reporting. And that's because they can't keep that information because it's typically PII, and if you can find that, you can eventually find out who the person is and potentially hack into that person's phone, right? So this is one of the error reporting, their use cases inside there. eBay does analysis with customers inside there. I'll talk a little bit more about what we do here just for a couple more minutes and then open up for any questions here. So when we look at discovery, you can't protect what you don't know, right? So that's the biggest challenge that we see with customers with inside sensitive data and doing analysis is there. If you don't know the data that you have, you can't protect it. And we can do data in motion or at rest. And we do it through a couple different ways inside here. And you see for Hadoop and databases and SharePoint, and we can do data in motion. We can look for pattern strings, patterns and grammar. So I mentioned earlier, this entire discovery process was created by Dr. Anand Singh, who wrote that paper, right, from AOL Stalker. So he wrote the entire process in there, and he wrote the whole process to look for contextual patterns or look for identifiers inside there to find sensitive data inside there. Once you find the data inside there, through the policies, you can audit, and we also do a thing, like I said, where we can do positives, false positives, unique identifiers, hits to see how confident we are inside that, so you can understand, are we hitting the values there, or are we creating other values? And inside there, you can then also throttle that up or down based on what you know on hitting a number, right? So the company I work with in St. Louis, they're looking for some unique numbers. When they saw those, they changed some settings in there to eliminate false positives and also some of the pattern matching, what was unique to them. So now when they have a hit rate, it's 90% that they're always finding what they're looking for. Working with a company in Milwaukee, they work with military, so you can probably guess maybe who that is. So military serial numbers are super important to them to always find and protect, because that's tied back to what the military, like vehicle or plane or rocket or something might be. So those can't be anywhere inside there as the sensitive information. When you look at data protection, there's different ways to do it. Masking and encryption. So again, like I said, there's full-blown encryption, there's full-blown masking, right? There's a lot of different people that do that. Your Hadoop distributions, Cloudera, Hortonworks do that. What they don't do, what we do different, is at the element level. So you can just encrypt one value and then allow users who have access to group policy just to decrypt that value, but see the rest of the value inside there. When we talk about masking, you can replace that value. And masking can be done a multitude of different ways. We have, I think, 43 different ways to do masking. So if you could think of it, we can mask it inside there. Masking, remember, though, is a one-way operation. So if you mask something, there's no way to get back. It's funny because like every customer, when I start working with them, always wants to demask information. And I'm like, So you do it like American Express does. They copy it to a different column and use access control again to stop that, but most people don't. And the reason that is not done, and whether it's DataGuise or any other company, the reason no one demasks anything is because if you demask stuff, you'd have to do what? You'd have to store the original keys in a lookup table to demask the values back to the original values. So what you do now, you just kick the can to DataGuise or X vendor is now the next security breach and security hole, right? Because they have the keys to the kingdom because they're storing all that data. That's why there's no way to demask that. It comes up constantly when people ask those questions. I'll show you a couple of things here. So this is unstructured data, right? It comes in there, it's the raw data. If you're looking at certain elements inside here, you're deeming them as critical, right? I don't want to know these. I can go in here, performing a masking operation, so everything looks identical to what it looked like before, but it's not real data. And again, when you start looking at the world of Hadoop, you start doing some analytics and reporting in that. We look at Platform or Talon, some of those visualization tools for reporting on top of Hadoop. They still need the data in correct format or contextual format when you bring it back. So then you have to, if you want to protect that data, you have to mask it or format preserving encrypted the data inside there so it comes back like it's logical data, right? And this is an example of unstructured. Here for encrypting the data, right? It's still in place inside there, and we can do this for structured or unstructured data. The big thing we see, especially in the world of Hadoop, is customers using unstructured data, right? They're pulling any type of data source in that you could have, and then want to do analytics on it. Here's the cell or just the row level. You can see this. Here's another example of unstructured data just actually doing it at the cell level below. So you see above is the real data, below is the data's looking like there. You can X out, hash it, you can put any numbers, you can do any type of data analytics inside there. And then really, it's when you look at the data inside there, you look at how do you protect this and how do you create data governance across the whole spectrum. I want to make sure sensitive of time here to make sure. Any questions? Yes.
I had a question about that general technique where you, whatever technique of obscuring or encrypting the data so you could still run your analytics against it. Is there still a chance that you could actually get back to the original data because there's so much of it in so many places if you use that same value over and over again to represent the same data?
Yes, we do. Masking customers do it a couple different ways. I've seen it depending upon how the data is, the analytics. If something's like a primary key, right, that you have relationships off of it, we can maintain referential integrity when we do masking. So we'll store that and we'll change my social security number every time I see it to be the same masked number. So you can do that across there. You can see the individual, but there's no way, because once that's masked, change to get back to it. No way to see that. I have this question come up. This actually has come up a couple times in the last couple weeks. Someone's like, well, what if you change phone numbers? It more than likely might be somebody else's phone number. And I was like, I never thought about that. I'm like, you're correct, but it's probably not Chris Spacco's phone number. But it probably is a real phone number. If you're going to dial those digits, someone's going to pick up on the other side, right? And that's what they were talking about. Was like we were talking about format masking, even social security numbers. I'm like, that social security number is probably somebody's social security number. It's probably not Chris Spacco's though, attached to the name. So to answer your question, there's really no way, if you do it like that, that you could get back to what the original value
not
is.
With that data, but perhaps, and now I'm talking larger, big picture, it's almost like a factor analysis type technique where it isn't that data, it's some other data that consistently shows up with it. And if you have enough of it, you could go, oh, that really means your social security number, your real social security
If you don't do all the data, yeah, absolutely you can. And this is the customer I'm working with, the healthcare provider. Like I said, they gave access to 145 people, like from 20 to 145, and they have multiple tools, right? So they they want us to do detection on it. They're doing a different solution for encryption. They're going to use us for their dev test cluster, where they're going to allow even like hundreds of people to access it, but they're going to do masking there, so they're like there's no coming back from it. And that was their original problem, is that when they were dumping stuff in there, they were doing access control, but they realized in Hadoop, as you start touching other files, that people could technically like run a query, map our job, and touch other data that was linked to data to start stringing the data together. And that's when the whole project came to a screeching halt for a second, because just like you said, they realized that you're only a couple parts away from actually getting to where there might be some real data inside there. So that's when they changed the whole theory and what they were doing with it. And that's where, that's where you also get to the, I didn't mention, I'm seeing more and more people set up multiple clusters. Like some people are actually creating a landing zone which is 100% secure, and then desensitizing or scrubbing through it, and then dropping it into the data lake, and then allowing users to access it. One of the customers, their big use case is they're doing offshoring, and they were actually going through and cleansing the data before they were offshoring it, and they wanted to get out of that business, and like, if you can just do the detection, we'll just do the abstraction, deleting it, if you find that for us, because they send all that off for other analytics, right? So it's like getting more and more complicated, and depending upon what your end result is. Yes?
Yeah, among the persona that you'd be dealing with would be the federal government. I'm thinking Homeland Security, I'm thinking immigration, I'm thinking the various people who'd be interested in drilling down into some of these data storages. And I'm just wondering, obviously you can't give specific cases along these lines, but have your clients been happy with the relationship that they can have if they do get a request for information about certain individuals who are under suspicion?
Yeah, so we have one person that just works with the federal government team, and that's part of it. It's shocking because the government, I thought would be slower behind with Hadoop, and they're actually farther ahead than the general population in Hadoop. And the reason they see analytics, just like you talked about, is it's more about they have more data than they know what to do with, and how do they get the data, and then how do they contain the costs of the data, right? When you look at it, if money was no object, right, we'd all stay on the mainframe, or we'd all have giant Teradata clusters, or there's multiple different ways to do it. So they can get to the data, and that's part of the thing, is they're looking at how they allow more people to see analytics, but not see certain things about them, but then identify that Chris Spacco is someone we need to look at, and then there's somebody else who can see all of my data, right? Government's big, healthcare, medical, retail, credit cards, like you saw Visa, American Express, are using, like Discover are using us, banking. We see a lot of it in this level, medical records and processing, financial institutions, anybody that has a lot of sensitive data, like especially PII, PCI data, that's where we're starting to see it. And like what we do and some of our competitors do is, like I said, it's that data centric, it's that next level where a lot of people say we have enough, right? We have Kerberos. No one can get to anything unless they're on the network until something happens, or the big explosion of unstructured data. One of the insurance companies I'm working with, everything that's done in the chats, like that's almost becoming more prevalent than people calling in, or people emailing, like contact us, don't send us anything sensitive. He's like, you'd be shocked how many people like put their account number or credit card in there, if they missed a payment. And he's like, all that's unstructured data. When you have all that, how do you, they encrypt it all on the disk and everything, but then it's still like they're storing all that data, like I mentioned. Yes?
So you mentioned early on about how, based on like zip code and gender, being able to identify somebody. So do you take the strategy of like locking down all of those things, or if like you have a combination of like 5 things where any 3 will identify someone, do you let people pull up 3 of those 5 and then stop them there? Or like, you see one?
Yeah, so that's a great question. So he's saying, like, do we lock down, or how do you stop people like pulling those 3 data elements back and then actually figuring that out? We don't do that. We're an enabler to find what you would deem as sensitive data, right? So if you're healthcare, it's HIPAA or PHI data, right? If you're retail or doing anything with credit cards, your PCI or potentially PII data, right? If you're insurance and other things like that. So you would determine what's sensitive to you, and then determine what level to be in compliance, like you would need to lock it down, or who's accessing it, even if you are gonna lock it down, right? Like, it's a couple customers I have, they're using us to find certain things in the detection process, and then they're only locking down those items, and there's still a lot more sensitive stuff they're letting through that they're allowing people access to do reporting on, right? So it's really up to you. And again, like I mentioned earlier, to that healthcare provider, they deemed like group ID sensitive to them. But if you and I or anybody in this room just got the number, it'd be like a random number, would be like, I don't know what it is. It's a group ID. But to them, that's their world. Group ID and the date that your expires are, to them, that's like the secret sauce. They believe if anybody can get that group ID and the date, they could hunt an individual down and create insurance fraud or do all sorts of things against your claims. But to anybody outside those walls, it would be a number and a date. I'd be like, I don't know what this number and date are. But and again, that's what they deem. When they're putting stuff into their data lake, they're like, we want those values masked all the time for a certain group of people, because there's a certain group of people, as being an insurance and medical provider, they want to find out information about me, my age. I live in Chicago, and I have allergies. Because potentially, is there a way that too many people have allergies, right? Do we make something better, or do they do something preventative to stop people from going to the doctor for allergies, right? Because there's a cost to that. So it's stunning how, like, when they look at big data, they're just mining that purely, for them to do analysis, right? To determine, is there a better way to do something, or is there a pattern or theme, or is everybody in Madison catching the flu? And if you're getting emails, you all send emails about flu prevention, right? Or market additional policies. It's, you don't think about it. It's crazy how big of a business it is, just from a preventative standpoint, but also from like how they can help individuals out, right? But they need to know certain things, but not other things. Yeah.
How do you specify the rules that exist for people to customize sort of the masking policy or any sort of encryption policy or whatever the case may be through a product?
Okay, so the question is, how do we specify the rules, like we said there?
So like
out
the
of the
insurance company,
yes,
they have the policy number, the date that follows it. That pattern is very important to them. You mentioned regex. Are you doing anything else?
It's a smarter version of a regex, right, through a GUI editor. So we have out of the box HIPAA, PHI, PII, and PCI, because those are the standard ones, right? Everybody wants to find a social security number. When you look at their group ID number, we just went in there, created a specific thing and say it's going to be alpha and numeric. You can check those boxes when they're looking for it. You can say afterwards we're looking for a date, and they know the date format we're looking for. So you can put that in there, and then you save that to their group ID discovery. They also had things like names before. I had other customers who know there's like, it's going to be an address, an identifier, another thing. So you can build that in there. You can also upload lists if you're looking for things. So I had one customer, like, these are all the numbers we have. We can upload those lists, and then we can go hunt for those numbers. Or we can do exclusion lists if you want to inside there. So there's a lot of stuff that's very unique to customers outside of it. I always try to talk about that because it seems like we always talk about social security or credit card numbers, but there's so many other things that are important that people look for. One customer wanted to look for everything in the email address, right? So we're hunting for, whatever at whatever dot, 3 alphanumeric characters afterwards, so we find that email address. Because they were hiding those because how their business works, that's how people register. So that became your registration ID is your email. So like we need to hide that, because if we don't hide those, anybody doing analytics on there, you basically have half the answer, right? If you're trying to create some fraud, you know what the user ID is, and now you just got to try to figure out random passwords. And if you have enough of those, randomly, if you type enough pet names in, you're probably going to you know, come up with, or type the word password and you're gonna come up with a hit, right? At one point in time, yes.
I'm just curious, so when you're talking about unstructured data, are there any limitations when it comes to scanning? Unstructured data, like for example, some of the unstructured data could be just handwritten, or it might be part print,
Yeah.
part handwritten, or it could be full handwritten sometimes.
So the question is
So how do you-
unstructured data, how do you look through it? If it's handwritten, how are you storing it? Is it,
So
are you,
it's
you just scan, so it's just images, or?
Right. So sometimes, so say for example, say legal contracts. Some of the legal contracts are fully OCR.
Yeah.
The characters are printed out. There are some contracts where part of the text is all printed, but then there's some stuff that's handwritten, address of the location, or a certain thing that is handwritten. Or there could be relatively older documents where there's more substantial handwritten
Yeah.
content. So I was just curious to know, in your pattern matching process, I mean, what has been?
Yeah, so we can do like OCR compatible, we can't do things where it's just like a graphic image. It's actually come up before where someone was like, had signed documents and stuff,
Sure.
and they asked us if we could do it, and I was like, no. I go, have you found anybody? He's like, no. So I was like, somebody creates that, but I guess it's kind of a specialized use case. We have had stuff that people have like scanned where they've taken handwritten stuff where they're OCR or parse it into text, and then we can look at it, but really anybody can kind of discover it, but it's that other step that we can see through, yeah.
And it's very challenging, that's why.
Yeah, it's and throughout my career at vendors, it's funny because people have certain use cases. I'm like, the answer is no, and I bet you there's no one else who could probably do it either. Yeah, no.
Do you do anything with probabilities of, how good the matches are?
Yeah, so when I mentioned earlier, we have a confidence factor
Yeah.
that we can come back with, and we can do things, quick sampling instead of full scans, right? If the data is petabytes, terabytes, or it's enormously huge, we'll go through and just do the like sampling scan, then we'll come back with a confidence level based on this. And that's where I mentioned the one individual, they had like 13 numbers and they just ran against it without looking for it. So anywhere we found like 13 numbers in a row, it took like a week to run. We came back and but certain ones where it was just 13 numbers, we're like, oh, we're 90% confident this might be your number. Where we picked out 13 numbers and 100 numbers, we're like, it might be 10%. You can change those values inside there. And again, you can do sampling to stop it from there. It's a law of physics, right? Whether it's us or anybody, even if you're doing your own home discovery. The customer I worked with in St. Louis, that was the same way. It's like, petabytes and teradata. And he's like, your scan ran just as fast as, we did because it's, probably even a little bit faster, but it found better data. And, it just becomes a law of physics. If there's a lot of data you gotta scan through, it's gonna take a long period of time. So we have some customers just doing quick sampling. eBay will do sampling for some of their analysis, and then right away just mask the data because they have a high confidence factor in it. So it's like, we don't want to have to go through a whole scan to do it. Because we have to when we mask data, the same scan principle gets reapplied because we need to find and replace the data with masked values. Because again, we don't store any pointers to any type of the data in the solution. We come back and report, tell you where it all is, but then when you want to run it, we go out and then find it and do it. We're running a little over here. I just want to make sensitive of time. Any other questions?
You mentioned you had, I remember, 23 different ways to mask data.
43.
43.
Don't tell me short. He's at 23. 43. Don't sell it short.
And it sounds like you're trying to balance, obscuring data with being able to access it and perform computations on it. Are you guys using homomorphic encryption for that end, where you perform operations on the ciphertext and then you just decrypt the result you want later?
Yeah. So for encryption, yes. So for masking, there's 43 different ways to mask, right? Masking is one way. There's no turning back. For encryption, we use standard encryption mechanisms, and then when you decrypt, if you have access to it, it'll be tied to your authentication, and then it will decrypt that data so you can get back to it. So you can store like our key, if you have a vault, like an encryption vault, anywhere all the keys are stored, you can drop our key in there too, to use it.
Right.
So the answer is yes. Encryption though too, we can also do encryption, we can also do format preserving encryption. So again, it's not fully, lengthy encryption. It'll be shorter if it's a shorter value, but it's still encrypted inside there if you need to preserve that data. We have customers doing both. Like for data democracy, they're doing masking and encryption. Because there's certain things that people need to see the real values and decrypt, but then there's certain things they don't want people to see those, but they want to see the format preserving masking. So we start to look at it, it's like, you have to, part of the talk is like to see it different, right? And how do we use it versus we're just gonna lock people out? Like what can we do? And one of the customers I did, they're creating 2 clusters now. And like I said, they're gonna mask the one and be like, anybody who's part of the business unit or anything can have at it. Yes?
I was just wondering if you run into issues where encrypted data starts to cause false positives on other sort of analytic searches, because you've got an abundance of encrypted strings of text.
If the data comes in encrypted and we're detecting on it, that could happen, right? We've had people, if they're doing like full encryption and they want to look for data, and after that, they'll do like create landing zones, potentially. So they'll decrypt it, create a landing zone, or do it like in memory, like in Hadoop, we can do things in flight. So they decrypt it in memory, and as they're doing like an ETL load during that process, we would do the discovery or detection during that process, and then they'll land it and maybe encrypt it again.
What's your definition? What is a landing zone?
So staging area, fancy name for staging area, or, but I forgot what there's like secure landing zones and stuff now. So there's people, like one of the customers I work with, because in medical they take everything in during the ETL load, and they actually have a completely locked down landing zone that only, it's like 2 people have access control to, so it's all part of the job and the process. And then from there, everything that we do that's in flight then gets dumped in to the final cluster. But the secure landing zone is like one of those things where there's nobody access to the final product. It's the production Hadoop cluster. And there's multiple ways, like, talk to some of the, like Anahad, our doctor, and there's multiple ways you see and you think about like how to do it. Sometimes people don't want to create separate clusters. Sometimes that's the best thing, depending upon what your end result is to get to it.
Sure. So you made a point about a phone number getting masked to another phone number, and that could potentially be a valid one.
Yeah.
So I'm just curious, why would we want to mask a phone number to another phone number? And why not something like A, B, C, D, E, F, G, H?
You can't, so the question is about masking a phone number, right? So I said earlier, my phone number might get masked to another phone number, which might be your phone number, right? But you're not Chris Spacco, so it doesn't really matter if you're looking for it. Why would you not just change it to, 1, 2, 3, 4, 5, 6, 7, 8, like you could.
Yeah.
So I've had customers that every time they see a phone number, they'll just say put all ones or put all X's, or or keep certain digits of it. Some people like to mask phone numbers like that, so again, it's real data if they're reporting on it, so it all looks real. So when you get the visualization, it looks like it's real. Some people want to keep the first 3 numbers, right? So it's Madison, so it's Chicago, so it's Milwaukee, so it's Green Bay, right? So you want the 3-digit number, but you want the rest of the numbers could be all X's, or they could be all 1s, or they could always be all 0s. It depends, like, when you look at this, when you start looking at data-centric, like security, it's what are the key values you need to use off of it, right? And what's important to you, or what are you reporting on, or what would somebody want to report on, right? So you ask that legal question, you're probably in the legal business or contract business or something.
Yeah, we do deal with a lot of.
Yeah.
Right.
So like if you're looking at big data, to me, I would say I might need the first 3 digits if I'm going to market to people to find out where I'm getting my business from, right?
And that's a good use case. So I was trying to understand.
Yeah.
Because I was wondering if it's an attempt to just trick the hacker, because there's no point in really tricking the hacker.
Yeah, and that is part of it too, like when people not trick the hacker, but when people get access, right? Like I didn't talk about that, but when people actually access the data, and your data is masked, where it looks like it's real, but it's not real, that's at second tier, right? After they got in there and get the data, they get it all back, but it's unusable. right? Because they might be missing parts of the credit card numbers or parts of the group or policy IDs, right? Or only the area code and the phone number is real to that person, right?
But it'd be nice if it was wrong in a way that was detectable. I know the hackers are smart enough to if it's obfuscated in a predictable way.
Yeah, well then they would know, right? But if you did just randomization of masking, it would always look like the hackers would think they got a bunch of real data until you find them, right? If you find that the data gets stolen, you're like, oh, they had a bunch of kind of semi-useless junk. They'll have people's names and addresses, but we can get all that on Google. I had a friend who was on the news and her tree fell on a car in front of her car, but the picture on the news was her car with her license plate number, and she was all freaked out about it. Like everybody could see my license plate, and she's like, aren't they supposed to, blur that out or whatever? And the most interesting thing I thought about that, and I was like, oh, well, maybe they do have a license plate, but I was like, she drives every day. Like I could see her white Cadillac, and I could see her driving with a license plate every single day. You know what I mean? Like, what is somebody going to get from that? I could walk around right now and write all the license plates, makes and models down. You know what I mean? So it was funny because she's like, I've sent an email to the news and told them they need to take that picture down because someone's going to find me. And I was like,
Well, it used to be in Wisconsin that was public information.
yeah.
Until I think they finally closed that loophole. But until then, you could do it that way.
Yeah, I mean, I live in Chicago, right? Like, I see people buy big houses in my neighborhood, and I was like, I wonder what their taxes are. I'll go home and find out.
Yeah, that's all.
Wow, he must be rich,
Yeah.
We didn't find out their latest tax bill and everything.
Right.
You just
Size
type
of the house.
You just type an address in. So there's a lot of information kind of at your fingertips there. It's just when you start to talk about this, I mean, really, what I hope if you went away from this is thinking about different ways to use the data, right? If you create a data lake, democratize the data and users getting into it, and how you can kind of secure it at the next level, A, to be safe internally as a customer, but then B, is there a way for us to gain value and leverage this, right? Because what's the biggest blocker of most projects? Security. Whenever you get to that one thing, big project you want to do it, and someone says, oh, that's, secure any type of data warehouse or any type of project like that, or people are like, that's always like, I've noticed sometimes it's the biggest blocker, is how do you think about that?
Nobody gets rewarded for highly secure, effective databases because no one knows that it works if it's really good. So it's a paradox. The worse the data security is, the more you know about it.
It's exactly. I mean, before on this side, when I was an engineer for years, I remember going to customers and doing like proof of concepts on test dev, and we could talk more about this at the bar. But I remember going in, to Oracle, right? It's kind of dating myself. I think it was like an Oracle 11. Because there's like a sys and there's a sysadmin password. People were like, oh, the sys password we changed. And I was like, I bet you they didn't change the sysadmin password. Password, boom, I'm in the database as a super user. Sudo root, create another user. That's why I worked for Quest Software, create Quest, central user, set up my own user. Well, they were trying to get permissions for me, install everything, get it done. The guy comes back, I'm like, I don't know. Like, did you get my user? I got a user. Then I go back and change that user there to everything back to the other user. While he was working on that, I installed everything. And then afterwards, I tell him, like, there's actually 2 system passwords in Oracle that some people don't know. And the other ones, they're like, no, we disabled that account. Okay. The world's a lot more secure now, but everything's like that, right? I mean, at least your neighbors can finally like lock down routers and all that stuff too. But typically that wasn't the same, right? Or they force you. On the customer side now, the vendors actually force a lot of that because of those problems, right? Like they force the passwords on you, or force you to have passwords, or force you to have encryption.
So if you masking a phone number to another phone number, if the phone number you masking is found in like 3 or 4 different places in the data set, would be matched to the same different phone number, or is it going to be?
Oh, so if you mask a phone number to another phone number, and the phone number actually exists in your data set?
No, what I'm saying is
Consistency?
Huh?
Consistency, are you saying?
Consistency, yeah.
Yeah, we will actually maintain referential consistency. So if we mask one phone number and change it, we'll change that number to the same number every time. And like I mentioned it earlier, that's where you want to maintain consistency. So if you're building any type of relationship, in databases, right, you're going to have that primary foreign key relationship. Same type of thing for Hadoop if you're doing reporting. You want to make sure that numbers, if you're keying off phone numbers, that it's always the same.
Yeah.
Any other questions?
Yeah. All right, cool. Thanks, Chris.
All right, thanks, you guys.
All right, thanks everyone for coming, and I'll see you next month hopefully. And if you want to go out for a drink next door, just wait for a few minutes here, and then we'll all head over.